Hello everyone and welcome to our group's project. And our project this week is about solving a game called Hashi Wokago. It is a standard riches game and here is our GitHub folder. We have the 10 input files here and some of the outputs files. Here are the main Python files that will be handling the functions. We have a main file here. And our menu is in the readme.txt and the requirements are like this. So if this is the first time you are visiting our GitHub, run this command on your terminal. It will install the PySat library which is needed to run this entire project. So now we will begin. You could just run the main function like this. It will prompt you to type either one of the two options. Running option 1 will ask you to say run how many inputs. The number you selected, for example, if it's 2, it will run from input 1 to 2. 5 will be 1 to 5 and etc. It will run all 4 methods, all 4 of these, on the current input. Some methods are really long, like brute force, and the time taken for each method is saved and printed out to console. We will just wait a little bit here, and there we go. All the answers will be saved on the output text file. That is option 1. Now if you were to run option 1 on, like, say 5 to 6 file, it will take very long. I suggest 2 is enough. Now run the function again. This time you select 2. Now you will select only one file from 1 to 10. Here are our examples. We go from 3 by 3 to 5 by 5 to 7 to 9 to 11 to 13 to 15, 17, 20, and the largest one 25. So I'm just selecting the largest example here. Now there will be 4 methods you can choose. If you are running on an example that's any larger than 7 by 7 or just 7 by 7 in general, I suggest selecting the first option because the other 3 might take a very long time. And there we go. If you select the input-10.txt, the outcome will be saved on the output.-10.txt. I run some examples you can see here. Let me just run another one. On file 7, first method, it was like this. The minus sign is a single horizontal bridge. Equal sign is a double horizontal bridge. The or sign is a single vertical bridge. The dollar sign is a double vertical bridge. And that is how it would work. Let me use it on a much smaller example. Let's second one. And run the backtrack. And we'll save it like this. Now, as you can see, when we are running PySet, it only prints the solution in time. But running backtrack will also show you the number of steps taken. What it means, we will dive in later. Let me run an example for A star. A star is the same as PySet, just prints the solution. And finally, example for brute force. Brute forcing is by nature very crude and very simple, and it's also the one that takes the most time out of any of these. While it's running, I will lead you to the core file of our folder with this. 21 seconds. But to the other, that's like 20 times longer. Here's our main class. It handles most of the function. The bridges are stored as variable here, and all the CNF constraints are here too. Here's our A star. Wait, we should start with PySat first. PySat will utilize the CNF generated from our core here and use the built-in PySat function to solve the problem. And for A star, the node is defined as the following. The G value and our heuristic is calculated as so. And here's the class itself. It runs through, follows the heuristic, and select the next best option. There's also a max node here to prevent infinite search and so on. This is our backtracking function. It's very simple. It doesn't use much of a CNF. It just counts the bit stages and the item count. It will try to place from 0 to 2 bridges or any possible bridge and make sure that it is valid. It satisfies all conditions given to it. Afterwards, it will, if it works, pass it to the next iteration. If it doesn't, reset and try again. And here's the brute force. Is generate a CNF constraint like I said, but in theory, like say for example, if I take this example, there are 4 possible bridges, but since they could be double or a single, there are 8 variable so bridges from A1 to A1 to to A8, and for each one it could be true or false. Brute force will test all combinations of these, so 2 to the power 8, and it will just try to find the one that is correct. It satisfies all clauses and solves the problem, which would be this. So this, its general nature is 2 to the power of n, with n being the number of possible bridges, to the power 2 to the power 2n for each singular possible number of bridges, since it be single or double, and it will generate all possible iterations. And so this is the longest one by far, but it's also one of the easier ones to implement. And yeah, let me run one last example here. 2, 6, and 1. There we go. Here's the solution. That is the end of our video, and have a nice day.